So let's look at a few examples involving the real and imaginary parts of expressions. Any complex number can be written as z equal to a plus bi, where a is the real part and b is the non-real or imaginary part. We state that the real of z is a and im of z is b. So take note that it's only b, only the coefficient without the I. So in A then, we have 2 plus I times 2 minus I times A plus BI equal to 10 minus 4I, where we have to determine the values of A and B. So let's have a look at the first two brackets. When I multiply this out, I can see that it's a difference of 2 squares. So therefore, it will become 4 minus I squared. And that stays, I'm going to leave this as it is, as well as 10 minus 4I. So remember, by definition, I squared is negative 1. So this will become 4 minus negative 1. And to simplify that, 4 minus negative 1 will be 5, because it becomes a plus. And I can simplify the bracket then further to say it's 5a plus 5bi. This is then equal to 10 minus 4i. Right, so when we work with complex values, complex numbers, in an equation, the real part on the left-hand side should be equal to the real part on the right-hand side. So there's my first equation of 5a will be equal to 10. I can divide by 5 and a is then equal to 2. In the imaginary part of these two expressions, I have that 5b is then equal to negative 4. Divide by the 5 and I get b is negative 4 over 5. Now let's look at b. In b, we have 2 plus I, a minus bi, equal to 8 minus I. So let's simplify the left-hand side. It's going to be 2a minus 2bi plus ai minus bi squared, all equal to 8 minus I. So take note of this term again. The I squared is actually minus 1. So let's put this all together. So 2a, and then I'm going to move this to the front to get all the real parts together and all the imaginary parts together. So 2a plus b minus 2bi plus ai is equal to 8 minus I. So from this again, let's put the real part on the left-hand side equal to the real part on the right-hand side. And the imaginary part, which is the a minus 2b, equal to negative 1. Remember, the coefficient here is negative 1. So I'm only going to work with the coefficients of I. It's not necessary to use the I as well. So there are my two equations that I have to solve simultaneously. In this case, you can choose the method you prefer. It can either be by substitution or elimination. What I'm going to do is I will take the negative 2b to the other side and I get a equal to 2b minus 1. And then I'm going to plug this into the first equation. So that will give me 2 times 2b minus 1 plus b equal to 8. So from this, we can solve for b. I'm going to times the 2 into the bracket, and I'll get 4b minus 2 plus b equal to 8. 4b plus b is 5b, and if I take the negative 2 to the other side, that will be equal to 10. From this, I divide by 5, and I get that b is equal to 2. Now I can plug this into any one of the two equations. I'm just going to put it into the second equation. And from that, a minus 2 times 2 equal to negative 1. So from that, a is equal to 3. So let's look at this other example. If z is given as a plus bi over a minus bi, right? And the imaginary part is equal to 1. Prove that a is equal to b. So, what do we do when we work with division? We are going to multiply with the complex conjugate of the denominator. So it's going to be a plus bi. And if I multiply it in the denominator, I also have to multiply it in the numerator. So what do we get from this? In the numerator, I will have a squared plus abi plus another abi plus b squared I squared. All over, and then in the denominator I can see that it's a difference of 2 squares, so that's going to be a squared minus b squared I squared. So let's simplify this then. In the numerator, that will be a squared plus 2abi plus b squared times negative 1. Remember that I squared is negative 1. And the same here in the denominator. Now this all simplifies to a squared minus b squared plus 2abi all over a squared plus b squared. And from this, I can split up the real part from the imaginary part. So I'm going to say a squared minus b squared and give it its own denominator. And then the imaginary part with its own denominator. So from the given information, remember they gave us that the imaginary part is equal to 1. So therefore, 2ab over a squared plus b squared is equal to 1. And from this, I can multiply with the a squared plus b squared. I take the 2ab to the other side and factorize. Now I get a minus b, and from this it is clear that a is equal to b.